time. You're seeing it more and more with people wanting to build, personal agent memory and personal AI and personal LLM compute, and you're seeing that as well with, the neural chips that Apple is providing. They're becoming more and more powerful, more and more capable. And I think the one thing that will define that is, we're not moving towards 100 billion, 500 billion, 1 trillion weight models. The size of the model doesn't seem to have an impact necessarily.
Welcome to Agentic Thinkers. I'm your host, Matt Elsey. In this podcast, we talk to the founders and CTOs actually building agentic AI, the real systems. We cover everything from design, governance, to the hard lessons of scaling in production. If you want the reality of agentic AI in the enterprise, hit subscribe, because we're just getting started. Today, we're diving into SurrealDB, a highly scalable multimodal database built entirely in Rust. Most teams end up running multiple databases: SQL for transactions, document stores, graph for relationships, and now vector for AI. SurrealDB looks to put an end to that sprawl by unifying them all in a single engine. So if you're building real-time systems and AI agents, you want to stick around to find out more. I'd like to welcome Tobie Morgan Hitchcock, CEO and founder at SurrealDB. Welcome, Tobie, to Agentic Thinkers.
Awesome. Thanks for having me, and great to be here.
But before we get into that, I just want to introduce Rhys, who's my partner in crime at Agentic Thinkers. We've dragged him over the other side of the production desk to in front of the camera to be with us today.
Yeah, it feels good. Been promoted, and I was once told I had a face for radio, so it's good to actually be on camera for once.
Really good.
But yeah, good to be here.
Great, thanks for the welcome. So, Tobie, great to meet you. Want to talk a bit about SurrealDB. So, really want to look at where it all started. So I believe, and Rhys will like this because he's a golf fan, it's all started with golf. Not on the course, but something related to golf. So
I didn't think that was going to come up, to be honest. Hey, look, golf was an application we were building. It touched on a lot of the different difficulties or challenges that we built SurrealDB for. I wouldn't say it was the only thing we were building SurrealDB for, but it was touching a lot of those challenges. So SurrealDB is a multimodal database, and it was born out of the frustration of running lots of different database types. So a time series database, a document database, a graph database, relational, and there are other types as well. Nowadays, you've got vector and full text search as well in the mix. And at the time, we were building applications and kind of scalable systems that were built on top of these 4 or 5 different platforms. And running a small team, which was always the intention, it became hard to manage, hard to scale. The application was more complex because you were having to talk to 5 different platforms. You're having to deal with different data consistency models and everything like that. So that's why we started SurrealDB. One of those applications that we were building was a golf analytics app, which would track players as they moved around a golf course, and it would track all of their shots. And then you could go back in time and you could say, right, I want to find everybody who landed on the green in the 5th shot, and in their 2nd or 3rd shots, where were they? And therefore, how can we re-architect the course so that it becomes harder for pros, but not too hard for beginners, let's say. So, you can, because some courses are very easy for pros, but others are too difficult for beginners. And that touched on a lot of different types of data. So you have the GeoJSON of where that shot is in the on the course. You have the shots linked to each other. So the first shot is linked to the second shot. The second shot is linked to the third shot. You have general metadata around player gender, player handicap, player age, things like that. Weather. So time becomes a major part of it because you're looking back in time and saying, right, I want to look at the winter or the summer months. So it was quite a fun challenge. But yes, SurrealDB was born out of the general frustration of having to manage different systems, and today that's even more relevant with AI.
With AI, for sure. So that's temporal, and I saw something temporal augmented radix tree or radix tree. Radix tree. Sorry, I may mispronounce that. That's quite unique to what you guys are doing. That was a gap that you saw in databases, and there was nothing else out there that quite did that, right, over that time series piece.
Yeah. So my thesis was on radix tries, and I did a spell check actually at the time, and it was like, you've got half the dissertation wrong. It's trees, but it turns out there's trees and tries in that particular case. But it turns out, so actually our very first embedded storage engine called SurrealKV, which is inside SurrealDB, and it's used to store data in a graph-like format, but also with the ability to go back in time and say, how did this graph look at this particular point in time? That was built on a version adaptive radix trie. So that's effectively a tree which is built out of kind of the prefixes of all strings formed to make this tree.
Wow.
And then it's versioned with effectively timestamps, so you can jump between different versions efficiently without having to traverse large amounts of parts of the tree. And then the concurrent aspect of it enables you to modify it at the same time, as long as you're not modifying the exact same keys and values. That design has actually changed completely. We scaled to a point of that. It was brilliant, and then getting beyond that performance was a challenge. So we've now moved to a combination of a B+ tree and an LSM tree, which gives us better performance and better scalability. But it was the first iteration, and there was a lot of learning in it.
I bet. It's not. I mean, it brings me to another point. I mean, writing a database from scratch. I mean, wow. I mean, that's a big undertaking, I would say. I mean, we look back at the history of sort of Oracle, and I think it was a chap called Bob Miner who originally wrote Oracle back in the 70s, and look where that went. I mean, again, even that was a massive undertaking to do. I mean, how did you approach it? Did that feel like a daunting task when you discovered the need for this, or did you just sort of take it and run with it? Yeah.
I'd love to say it was all planned. I think if I'd known how challenging it would be, I probably wouldn't have started it. Right? I think that's the beauty of not having built a database before. Before that, I had used many different databases. And I love how many different databases approach and tackle problems. Let's say. But actually knowing the internals of it, that was something that I didn't have experience with, let's say, before I did my masters, and so that was definitely a learning curve. Don't get me wrong, we started conceptualizing this in 2015, 2016, and we eventually open sourced it in 2022. So it was a while before we actually made this thing public. We were using it internally, but there's a difference between using it internally for yourselves and then making it available to other people to use.
So it's a crowd. When Rhys, we were talking about the market out there is pretty crowded, isn't it, with other providers in the database space?
Yeah, obviously, being involved in the talent side, I always see lots of different companies that I'm targeting or hiring for, and vice versa. But I guess what we probably wanted to ask was where do you compare, I guess, to companies like MongoDB, Postgres, and their capabilities, and kind of what makes SurrealDB, I guess, different to those companies out there already?
Yeah, it is a good question. And there are, you can use SurrealDB for one type of data, let's say. So you could come to SurrealDB and use it in a very similar way to MongoDB. Just document, but it's document with the ability to query that same kind of JSON-like data with an SQL-like or a SQL query language. So it's very similar to ANSI SQL or the SQL that you find in MySQL and Postgres, with a few differences. That said, most people come to us with at least two models. So they come to us, we're using graph and document, and that is not something that other databases are built for typically. So SurrealDB has been built from the ground up to solve this challenge of multimodal data, so time series and graph and document and relational, but to be able to do that either embedding it within Python or in a mobile phone running at the edge, or to do that at scale across a 50 node cluster or 300 node cluster, which is storing petabytes of data. And we had to rethink the entire database for that purpose. It was not just like, we're building a document database, and now we're going to latch on graph, and now we're going to make it scalable, and now we're going to also latch on time series. The whole premise of the query language and how it works and stores data is built from this multimodal perspective in the first place. So how do we compare? Similar, you can store similar data to MongoDB, but we have also the ability to run in a schemaless or a schema full way as well. So it brings it more in line with something that you'd expect from Postgres or MySQL. It doesn't have joins, but it has join-like features because it has graph functionality and the ability to traverse through tables and tables and tables. And then other concepts like time series and vector search and full text search come into it as well as traditional indices. So effectively, if you come from any of those databases that you mentioned, it's very simple to get going with SurrealDB, but you don't have to use other databases alongside it.
Okay. So it's truly multimodal, not multi-feature, I guess.
Exactly. I mean, that's a big question about whether it's multimodal or multimodal, but something that gets confused a lot in the industry generally, and something I use interchangeably everywhere I go. But yeah, so multimodal is the typical traditional way of saying it. Obviously multimodal because there are different modalities that you can query your data with. You can store files inside the data, so audio files, video files, and images as well, which makes it multimodal. But it's not something you query per se. You can store and you can retrieve, but you don't query those different file types.
So with the multimodal thing, it's quite interesting because historically, and having come from the technology space, you end up gluing various databases together, and you got the sort of the overhead of doing that from transactions and latency in the system. And what you're saying is you're bringing all that under one engine, and it's all truly sat together. Because even some of the other providers will claim to do graph, and it's an acquired system that's been kind of bought in and bolt on. I won't name any names, but that seems to be the way they're going. There's lots of acquisitions in the database, and they're typically sort of traditional RDMS solutions. But everything's in the same engine for you.
Everything's in the same engine. When you run a query, it's either run in a read transaction or a write transaction, but effectively it is all in a single transaction as well. So everything is ACID, it's all consistent. When data is inserted into the database and you get that confirmation, the next transactions from then will see that data. And that's really important and something that's often overlooked, especially in the days of AI. So you've got vector search databases that are very fast, they're storing data in object storage, but they're not necessarily consistent, which is fine for lots of different types of applications. But when you need to ensure that, a transaction has been made, and we now need to, our chat agent needs to have an understanding of the transactions and the movement of money and the previous conversations, messages. This becomes, the consistency of that data across vector, across graph, across, how does this subsidiary account link to that parent account, and how does that link to company's house for the, HMRC, let's say, those links, those relationships, those vector queries, the relational queries, traditional metadata, like, find where this account country is UK, let's say, that becomes really important. And that is the one thing that, SurrealDB does not let you kind of drop down from, as it were. Everything is run inside a transaction. Everything is consistent, whether you're doing that on a single node with 1 gigabyte data or on 30 to 50 nodes on a petabyte of data or multiple hundreds of terabytes.
So that's quite an achievement, I would say, from, if you've got a transaction, you've got to guarantee it and then roll it back if something goes wrong. They're very different models to work with, I'm sure. You've got standard sort of SQL transactional, and then you've got, graph databases, which in themselves are very different. And then, AI vector embeddings, again, different in the nature of which they're used, although they're still records. That must be quite a complex transaction to manage and guarantee under ACID compliance or whatever you want to call it.
Yeah, and there's a reason that some of these, let's say, vector stores drop that consistency, or Elasticsearch has concurrent indexing behind the scenes, because it gives you that performance, right?
Yeah.
And you have trade-offs either way, right? You can either have really good performance, but the performance doesn't necessarily see the last minute of data, or you can have slightly reduced performance, which can also scale, but you're always seeing that last amount of data. I think coming back to your question, it's really important because we're not kind of attaching a different type of database onto this. It's all been thought through. So the ability to optimize those queries and improve the performance of these queries across the different types of data is possible, because we're not saying, right, this is a graph query, let's offload to some graph engine that we've acquired or that we've built on the side, and let's offload to a vector search. And the other thing that's important, you've mentioned providers who bolt on these different services. Those same providers have challenges with scaling because those bolt-ons scale differently. They work differently. They're spun up and managed differently. And because of that, yes, you can offer that functionality, but now you have challenges in how to manage it, challenges in the documentation around that. So, the ability to say, look, I have a system that I want to use for one type of data, let's say graph, or 4 types of data, but I can scale from a single node to 30 nodes to 50 nodes to 100 nodes is very appealing, especially when you're dealing with large knowledge graphs or large kind of amounts of data in large organizations.
Right. So I think if you look at it, and I use a Swiss Army knife analogy, maybe a bit crude, but you're quite new, so you're quite new to the game, and I guess to imagine in certain areas, other databases have a lot longer to get up to speed. So were there any challenges in not just becoming too generic? The fact you cover so many models and not specializing in one area where you could go really deep and get really good at it, and having to cover such a broad base. Were there challenges in that at all?
There's always a challenge generally. If you work with data, and especially if you've ever worked with databases are a trade-off, right?
Yeah.
You go for concurrency, you drop something else. You go for running in the background, you drop consistency. There are trade-offs in every aspect of the database stack. That said, if you build it up from the ground up, and if you build it up from the key value store to the query engine to the distributed storage engine, everything like that, then you have more control of that. Don't get me wrong. A database that is purely running the graph data structure as a graph data structure in memory, and the entire graph data structure resides in memory as a kind of DAG, or kind of graph structure directly in memory, that's always going to perform better.
Yeah.
But the downside to that is it can't scale. Yeah. Does it have transactions around it? There are lots of things that are to be taken into account. With SurrealDB, everything is stored in a key value like way, and it's the key value store that we then scale underneath. And the query layer, the query language, the compute engine is effectively just stateless, and it can scale on top. That does have a downside, and that we're not operating on an in-memory graph data structure,
right.
But it has the ability that we can merge these different models of data together and scale out as we want, and run in many different kind of environments.
So I'm going to ask you a specific question now. Are joins bad?
Look, I personally hate joins, the developer, right? And I don't know of a developer who likes joins. That said, AI does make them a lot easier nowadays because you don't have to understand what's being written. But joins are very efficient for single table lookups, and especially if they're written correctly and the correct indexes or whatever apply to the tables. But I think the most important thing is that a lot of the data nowadays isn't just. If you jump back to when MongoDB made document databases a thing, and because of the scalability, one of the things you had to do was you had to either duplicate your data up across different documents, or you had denormalize it, and that was the approach to that challenge. But really, it's not really how data should be stored, right? It's just a way of getting around the challenges at the time. If you think about how we model data in our minds, we don't store things in tables. We don't think about things in spreadsheets with columns of 1, 2, 3, 4 that maps to another spreadsheet of 1, 2, 3, 4. That is not how we think. And the other thing is we don't just think in terms of two tables. I think in terms of I work at a company, the company owns these assets, those assets also relate to other people. We think about multi-level deep relationships, and whether it's with SurrealDB or anything else, modeling your data in a graph-like format, and this is something that obviously Facebook's been doing for a long time, is the natural way of thinking about data. So don't get me wrong, joins are very good. There's been a lot of research over many, many years into joins and the mathematical functions behind them, and then the performance, the optimizations, and the efficiency of them. But from a developer's perspective, they're not the nicest thing to write. And from a scaling perspective, as you go beyond two tables, they do definitely fall down. I think everyone's experienced that. So look, they have their place, right? But I'm a big advocate for graph queries and the ability to traverse data like a human mind thinks about it.
Very balanced. We won't get any sort of haters on the whole sort of pro-join camp on here now, I guess. So I think you touched a bit on normalization, and this was a thing for so many years around we need to normalize the data, and there was sort of some dark art around it, and there was people that built careers out of normalizing data. When we move into this more unstructured world, especially with the advent of AI and also big data essentially beforehand drove this, is that changing? Because I think the reason I ask that is people almost get lazy now with data structuring and just throw it in unstructured, put the document in there, it will take care of the rest, right? And it's a lot to put on a database to then deal with all these different modalities. I'll use that word there. How's that pan out? Where do you see that going, and how has it evolved?
It is a good question. I think 4 years ago, let's say 6 years ago, there were different databases that were seen as ancillary databases that may not be necessary in most organizations, but in large organizations, larger deployments, you might get to them. Graph databases, time series databases, full text search. These are all things that you could do. You could do most of your application, let's say, on MySQL, and that was it. You didn't really need much more. That's completely changed with AI. Now you're seeing, right, we need to use RAG, we need to use vector and vector RAG, we need to use graph RAG, now we need to use hybrid RAG, and actually we get better results if you mix vector search with BM25 full text search. And then we need to have an aspect of or understanding of time. We need to understand, I've indexed all the emails across the organization. That's forming part of the agent, let's say, the agent knowledge. But I need to have an understanding of, does this question that the user is asking, is it relevant to the last 2 days of emails about this ticket, or does it now relate to something 2 years ago, 4 years ago, 6 years ago? So, but the agent needs to have an understanding of time. So now suddenly time is an important aspect, whereas it wasn't before. Time was always seen as, okay, we've got an event log for security or auditing purposes, or the ability to go back in time if a mistake is made. But really, time is now a fundamental part of the context layer with which agents are working. So, these different modalities have become more important. Now, don't get me wrong, things are being built very quickly right now. More and more people are turning to AI, and we're building things. You're able to build something that took 2 months in a matter of hours now, which is insane. And with that, data may not be stored in the correct way. If you actually look at some of the code that the AI is writing, it's not necessarily making the best decisions all the time, unless you're drilling down and prompting more and drilling down and prompting more, but you have to have that understanding yourself. And what you're saying is correct. There are always going to be challenges with just storing any amount of data. But that's why I think something, so SurrealDB is a document graph database under the hood. We're storing data in documents. You can store arbitrary data in each row of a table completely different. You could sort, everything could be schemaless, and document A could have 30 fields, and document B could have 45 completely different fields. And I think there's a benefit in that to an extent. It's very beneficial to get going, to develop quickly, to iterate, and which we want to do nowadays. But you need to be able to move towards schema full or schema typed data, because your application needs to, at the end of the day, even if that has arbitrary depth objects and arrays in a JSON-like format, it needs to have an understanding of the schema behind that data, and that definitely makes your application kind of more production ready. So today it's even more important because these different database types are becoming more centralized and more important to the context layer for agents and for AI apps generally.
Yeah, I mean, that sounds like that temporal time series approach is, you kind of hit it at the right time, obviously. I mean, clearly you timed it well, because there is that expectation from people when they query that they expect. You see a lot of it shared around in the press. I spoke to AGPT and it came back and was out of date. No, this is terrible. And it's because they were trained until a certain date. I guess that sort of influx of data is absolutely critical to be able to query across that as well, and know when it was valid, because obviously data ages and people are far more attuned to things being out of date and inaccurate because it was true yesterday, but it's not today.
I mean, there's so many different aspects. I personally love time, right? The aspects of time within our data is something that most of my dissertation was on that aspect. So time within graphs. But you've just mentioned another kind of form of time, which is when do things stop being relevant. So you've got the ability to say when it's most relevant, when things stop being relevant, what did it look like at a particular point in time? That's another thing which is totally relevant. If I want to try and get some determinism in my AI agent, I'm in financial services, I know my agent or my LLM is going to give me different response each time, but can I almost guarantee that the input to that LLM is the same each time? And that data may have changed over time, but can I go back and see the data as it was at a particular time so that I can feed the LLM with that data and maybe get a different response, but knowing that it's got the same input? That's just three or four types of time that I said. There are many different forms of time. You've got the auditing aspect, the understanding how people in the organization have changed that data over time. Data protection aspects as well, being able to say, look, this is no longer relevant, we need to be able to clear this data out. There are so many different aspects of time in data that many organizations overlook, or it's never really been a big part of data as a whole up until now. And I think it's becoming more and more important. So, I think we're not quite there yet. Right now, people are still figuring out how to optimize vector and vector RAG, and they're starting to get into graph RAG and hybrid RAG. But it is going to become a big part of agents as a whole, because agents need to understand the difference between something that has happened, something that might happen, something that has happened recently and is more relevant, and the relevance of data generally.
Because when I was researching this, it was quite interesting. Historically, people have done audit and journaling and just transactions with huge amounts of disk space and huge amount of inefficiencies, I guess, from doing that. You're essentially just copying and journaling out. Whereas it's different with SurrealDB, isn't it? It's quite optimal in how it stores that. I think it was sort of likened to like a family tree, where you don't just reproduce the entire family tree. So you just capture the diff, similar to GitHub, I guess, in fact, where you just post diffs or differences rather than the whole piece. So I think that sounds logical when I say it like that, but historically that's not been how it's handled, right? It's been handled incredibly inefficiently previously.
Yeah, and not just that. I think that comes back to the point that actually this hasn't been a kind of core functionality. It's been there for kind of an audit trail. That's often why it's there. Can we go back and see what a record looked like, maybe one record, and can we go back and see the data, the changes that have been made by any particular user over time? But really, it's far more than that, and the ability to query that is ever more important. Yes, there are different ways of storing data in SurrealDB. If you're storing 1,000 changes to each document in a table over the last month, that becomes very costly to store. So you want to be able to store that, as you say, with just the elements that have changed, with potentially snapshots. If you want, that has a downside to it as well. Just thinking about it now, if you store everything as a diff, if I want to go back 3 months and there are 1,000 changes between now and 3 months ago, I'm going to have to go back through every single diff to build up the document as it was at that time. So then you have to build in snapshots. The more snapshots you have, if every single document is a snapshot, i.e. the full change, it becomes more costly. So you want to balance the performance with the storage cost, and that is why. So one of our new distributed storage engines sits on normal compute, let's say in a cloud provider, but stores its data on object storage. So if you are storing terabytes and terabytes of data, but most of that data is historical data, and you're only really querying the last 10% of the active data of that, then you're not really paying large amounts of costs for that inactive data to sit in active hard drives or SSDs.
That's a good way of looking at it. Yeah, absolutely. So we touched a bit on AI. I know that a big part of it, I think it's datagenetic is what you have inside Surrealism. I'm dropping a few sort of SurrealDB terms here, so please correct if I'm getting them wrong. But that's a big area I want to explore a bit more around how that agentic AI sort of folds into what you're doing. If you could explain a bit more around that would be great.
Yeah, I mean, there's so many terms right now, and things have changed so quickly. Datagenetic was something that we just used last year, but effectively what it is the ability to add functionality to the database so that you don't have to scale out to a serverless platform or serverless system and increase that latency between an event that happens and then you running a kind of piece of code or logic based on that event, but to be able to bring that logic directly into the database. So effectively, when you are, let's say building an agent that acts on data and that data changes, and you want to have events that run based off the back of that can happen immediately right within the database. So you can bring your custom business logic right into the database now. Beforehand, you could do this with stored procedures, functions built right inside the database. Now you can build those functions with your own CI pipeline. You can test them without having a database running. You can build up everything outside and then bring it in and release it and version it inside the database. So it makes building custom logic, whether that custom logic calls out to external APIs like Anthropic or OpenAI, or whether it calls out to Stripe to make a payment, or whether it calls out to a secure enclave system to get an understanding of user data that shouldn't be in the database. These are all things that you can do and then have that data running right inside the database. So it just is another way of improving that latency, improving the performance, but being able to extend and improve the capabilities of the database.
Okay, so you mentioned there being able to call out to LLMs. Obviously, that's pretty powerful in itself. That does introduce non-deterministic behavior inside a database, which I guess would be an interesting concept to have to deal with. Do you foresee there being maybe local LLMs inside the database? Because it sounds like, we had the stored procedure world, which was well known, and we had sort of, Java sort of scriptlets being embedded in databases, and they're very much sort of transactional plugins that did slightly more complex processes, I guess. Me coming from my background as a developer, so bear with me. So when you start to introduce call-outs to LLMs, I would imagine that's a different kind of world. And do you foresee that maybe sort of smaller language models being embedded in the database? I guess would be my question.
100%. I mean, it doesn't change the determinism of it, right? You've got something running locally as opposed to something running remote, but ultimately at the end of the day, it gives you a result that is different each time. I think, look, that determinism or non-determinism is down to the developer. If they want to call out to an LLM, whether that's through the database or whether that's in Python or whether that's in JavaScript or whichever other language, the response they get has to be validated, has to be approved, whether that's approved by their application code or whether that's approved by a human. At the end of the day, their choice to insert that data or not into a database is up to them. But yeah, look, there's no doubt that the world is moving towards, let's say, more towards the way that human intelligence works, if that makes sense. And human intelligence is non-deterministic, and therefore, this is, LLMs are not. I don't think LLMs are going to get to a point where they just always give you the same output. There are mathematical models that are coming out which can be deterministic, but I think generally speaking, these generalized models are going to give you non-deterministic output, and the choice is up to the developer as to how they deal with that output. But having that inside the database, whether it runs inside a transaction or not inside a transaction, those same functionalities for a developer apply. The ability to verify your data, the ability to confirm that it kind of adheres to a schema before you insert it, before you store it, before you act on it after that. That's totally possible. So we are not making choices on that for a developer. We're leaving that up to the developer. And I think that's a big thing about SurrealDB. It's very featureful, but it's up to the developer how they use those features and use that functionality to build their applications. We're not opinionated, other than, it's all transaction based and this is how we scale. If you want to use events or triggers, or if you want to use live queries, if you want to use change feeds, there are 3 different ways of listening to data as it changes, as it were. And that choice is up to the developer. So
almost developer in the loop, maybe, on that front.
Exactly.
I guess the interesting bit with the smaller language models or the local LLMs is there's a bit of a shift now happening whereby people are sort of reclaiming their data, and I want to run this stuff locally, and we're seeing a bit of a trend there. I guess it's around those specific workloads. We talked the other day around sort of order to cash, procure to pay, domain specific models. That's all they know. They're very constrained around the guardrails in what they do, versus calling an OpenAI generalist frontier model or the Gemini, and you'll get back a very different result because they haven't been as tuned. And I guess I'm just sort of assuming that direction might help with getting that still non-deterministic, but a bit more deterministic behavior within a transaction, which I guess also it has to happen reasonably quickly. I mean, if you start bolting in calls to various models, that's going to slow that transaction down.
It does. So every transaction, first of all, in SurrealDB is optimistic. So it doesn't matter if it takes a long time to run.
Okay.
I mean, you can limit the length of time in the configuration, but it doesn't matter if it does, as long as it doesn't alter data that hasn't. As long as it doesn't alter data that's been altered by another transaction at the same time. So we don't have table locks. There are no locks inside SurrealDB. So when we build indexes or vector search indexes or full text search indexes, we are running those concurrently in the background. And there's, so we could handle large, a massive table with large numbers of records, and it wouldn't lock up that table in any way, which is very important. And everything we build in SurrealDB has to have that, because we're designed to scale. Coming back to your point, I realised I didn't answer that in the previous question. Local models are incredibly important, and it's not just local models. People think, local running this locally and giving me privacy is important. It's also about the data, and people, we're storing beforehand we were like, oh, Google takes my data. Google didn't take anything near what we're putting into an LLM. All right. So, that the memory, the context, the understanding of who we are is being stored in the cloud. It's being, right or wrong, don't get me wrong, that's giving us great benefits, because these LLMs and these chatbots are giving us, great things that we didn't have before. But ultimately, especially when it comes to enterprise AI, the ability to run those locally at the edge in employees' devices or on phones. We're seeing that change. Obviously, with robotics, that's going to become even more important. Pushing that data up to the cloud is going to be costly. I think that's the other thing, right? Cost plays a big kind of part in this. It's very, it's amazing to be able to write an application, 10,000 line, vibe coded application in a matter of minutes. But cost wise, if we can run that relatively well on my phone or on a laptop, and it takes half an hour to an hour to generate that same application, is that good enough? And especially if it's not going to cost me anything for that. So there are two aspects to this. One, the ability to call through to local models or local GPU. It's something you can do in a database as well. But also the ability to store that memory locally and not push it all to a cloud provider. Now, we're at the beginning of this, well, almost. We're almost at the beginning of this wave, but that will come in time. You're seeing it more and more with people wanting to build, personal agent memory and personal AI and personal LLM compute, and you're seeing that as well with the neural chips that Apple is providing. They're becoming more and more powerful, more and more capable. And I think the one thing that will define that is, we're not moving towards 100 billion, 500 billion, 1 trillion weight models. The size of the model doesn't seem to have an impact necessarily on the quality, but the context of which you put us alongside that model, whether it's just vector search or whether it is some kind of historical vector graph data, that is what definitely can improve the output of a model and the kind of understanding and reasoning that model has. So really, if we're not increasing the size of the model, it means that we are able to load these models that are becoming more compact and better locally, and that is definitely going to become a big part of this AI wave.
So that surrealism piece, I assume that's right. That's still valid. It was a data agentic that's been moved on from. So the surrealism, that's a kind of developer space, right, where people are doing their own thing. And how does that look? Do you want to explain a bit more around surrealism and what that actually means? It sounds fantastic, right?
So surrealism is the ability to build functions in Rust or in JavaScript, and to compile those into a WebAssembly module, and that WebAssembly module can then be loaded into the database and run. And you could run that WebAssembly module every single time a triggered event that takes place, or every single time a record is updated, or every single time that a webhook is called. It can effectively act on things. You could also say, look, I want to use this WebAssembly function and update all of the records in this table, and it would just going to kind of apply itself to 1 million records or something. So you can use it effectively in any way that you would use a function before. But you can have that logic completely separate from the database. It can be versioned separately. It can be developed separately. It can be tested and deployed separately as well. So that's the kind of beauty of that. It's one part of the puzzle in SurrealDB though. Surrealism enables you to extend the capabilities, but then we've also got the ability to run machine learning models in the database through to Onyx as well. So you can run this directly on GPUs. We have the ability to call out to APIs, so the ability to call out through HTTP to Claude or ChatGPT or Gemini. So it's one part of the puzzle that makes, it enables developers to build what they want.
Because it seems like a community-driven thing. I mean, quite niche, but I run an Unraid server, for example, and I just sort of looked in their app market, and there it was, SurrealDB. I downloaded it, I've got a Docker image running there. So are you embracing that sort of community that's out there, the developers, the open source?
Yeah, I think it's hard to, in this day and age, right, not to do that. Especially, people often think of open source as, it's attracting the indie hackers, the hobbyists, the developers. But really, a lot of organizations are not going to trust a database if they can't understand how it's built and see its community benefit as well. Because, rightly or wrongly, that's just the way that the database industry has gone, right? And there are a few kind of proprietary closed source systems, but the ones you've got to compete with are the ones that are open. And so don't be wrong, that is one reason. But also, if you want to build something for developers, you have to get the developers understanding that what you're building is right. And the best way of doing that is building an open source platform where people can say, oh, I love this, but could we have this, or can you do that, or actually I can contribute back and add this functionality in. And don't get me wrong, 500,000 or more lines of Rust code is, or was before today, a challenge for anybody to just kind of come and contribute to, but it still allows people to do so if they want to. And today it's obviously even easier with Claude and ChatGPT and the ability to write good code without having the full understanding of how to write it.
Yeah, I think it's quite traditional in the product space, especially when companies always have an open source area. Like HashiCorp did it brilliantly with Terraform and stuff like that. And like, I think you've got quite strong roots in that open source side with Surrealism and so on. But like, could you kind of explain, I guess, what the plugin architecture kind of looks like, and maybe where Surreal MCP kind of fits into that?
Yeah, I mean, this is the thing, right? Today you have to build so many different connectors of different platforms and libraries and frameworks. I think SurrealDB is built from the ground up. We have our own binary protocol, we have our own query language, and that's one of the challenges, because we then have to go and build our own SDKs for every language. We have to build our own ORMs, we have to build our own MCP server. If you're built on top of Postgres, there's a massive ecosystem which you just automatically tap into because it's Postgres. And that is, so that's something that we've been building out, and we continue to build out. So for agents specifically, MCP is obviously one that many people have heard of, if not everybody's heard of, if you're working in this space. The ability to spin up a server which allows you to start up a database or communicate with a remote database that's already running, or manage a database in the cloud. So it enables your agent to make choices based on what it thinks is right around data in the database, or spinning up and managing databases in our cloud, or managing our own infrastructure as well. That's one part of it, because to integrate with people are building agents in very different ways, and I think the other thing is people are iterating and trying and working out what works best, and no one really knows that answer yet, because first of all, it depends on the application. It depends on, are we building a very simple chat app or a website here? Or are we building something that has an understanding of an entire organization's knowledge, from emails to events to documents to recorded meetings to everything, right? And that they're very, very different problems to solve. But that said, so we have MCP, which enables agents to work with the database and to manage the database itself. We have our own virtual file system that sits on top of the database, and effectively it enables you to store markdown documents or whatever the LLM decides to create. So LLMs have a great understanding of technology that is well documented online. Mm-hmm. And one of those things is Unix file systems, right? There's many, many documents out there. So LLMs have a great ability to work with file systems, and if it can list directories, create directories, add files, remove files, edit the contents in files, that is effectively a very good way that agents can store memory. So you can do that on a traditional file system, or you could spin up a virtual file system on top of Surreal, and then you could also analyze that data in a graph-like way behind the scenes as well. So it's just storing data through into the database, but obviously it has the ability to scale up to many compute nodes and many storage nodes, so you can scale up to terabytes and more data. We have Surrealism, which is the ability to run plugins directly inside the database. We have the ability to run LLM calls directly within the database, and we have the ability to run models locally within the database as well. So it doesn't take away from the fact that what we are building is a database that is there to store data, and to store that in a consistent way that someone like an enterprise would need and would expect. But the ancillary plugins and additions and add-ons and connections that people need today to build those apps, that's kind of this entire ecosystem that we're building around it.
Because there's quite a fascination, and maybe rightly so, I quite like with Markdown, right? And this is a way that people are now trying to control inverted commas, how their interactions with the models and keep them consistent and almost repeatable. And we're all amassing, well, I know I am anyway, amassing markdowns in folders, and it almost feels like we're going back to that. You mentioned the sort of the Unix days. We're going back to those basics, right? I do worry how much logic people are just storing in the markdowns on their folders, and it's not. Is there a way that we start to move that into the sort of the data stores, the databases, to start to maybe bring that into a central repository somewhere, rather than have this disparate kind of situation that seems to be evolving organically at the moment?
It does, and there is a limit, right? There's going to be a limit. And don't get me wrong, if you've got a large markdown file, or if your LLM decides to put it into, let's say, 5 folders with 5 files each, and it decides where it wants to look at any one time, then that is that's obviously great. The LLM can do that. But I saw a tweet the other day which was, we don't need databases anymore. We just need flat files on a virtual file system. And don't get me wrong, you can build a lot, and with Claude, I think you can now put a line of text at the top of your markdown files in the front matter which says memory project or something, and then it will start building up and storing its memory inside that markdown file, or inside a set of markdown files. And it's great to a point, and everything else is to a point, right? At the end of the day, if you're building a very simple system which displays all of the capital cities in the world, you don't need a database. You can do that from a list of 300 rows in a spreadsheet, or 300 rows in a text file, right? That has a limit. Markdown files will have a limit, and that is the thing. So I think it's important to be able to meet developers where they need to be. So if that is, the ability to say, right, I need a file system because I'm storing single thing in Markdown, and my agent, my LLM will kind of manage and understand what it needs to store and how it needs to store it, and build that structure itself, then that's fine. But the moment you need to go beyond that, and you need to start having a concept or understanding of how entities within your organization relate to each other, and how vector search is a way of kind of finding things that match in a similar way, but similar meaning, but not necessarily the same word. And full text search is needed to find actual matching keywords. This is when you need to start thinking beyond Markdown. So don't get me wrong, Markdown is obviously a great way of getting going, and we're seeing more and more of this. But and there will be things that come out of this for managing that Markdown and seeing that Markdown in a graph. And there are already those applications pre-AI where you could build up your brain, as it were, in a Markdown document, which was mapped as a graph on your app. I can't remember the name of it, but everything has a reason, has a pro, has a con, and you need to, as a developer or as an application, you need to work out which is the right route.
I think sort of reading stuff out there as well was, I read something interesting, which is around, you don't really need to understand what your schema is anymore, because you know what, AI LLMs are going to decide it for you. And it's almost that sort of topical thing around sort of, there's this, is it open claw, malt chat, maltbook, is it malt?
I've changed the name a few times.
Yeah, talking to each other in their own language, which is actually just of an offset of sequence of characters or something. Now, saying that you don't need to understand your schema, I kind of get where people are coming from, because some of them, got to the old normalization discussion, we're getting really complex, where they were not sort of in human language. It was just literally a number of references and numbers for tables. To what extent is that true, or is it true? Do we still need to understand how our data is structured and stored, whether it's unstructured or structured, but how it's set up, or can we just leave that to agents to govern for us?
I think it's a good question. I'll answer your question with another question, which is how long before developers, let's say the general developer, we won't talk about financial services or large scale enterprises for a second, but how long until the general developer doesn't look at code at all? Doesn't know how it's working, what it's doing. It just looks right at the end, and that's all that's good enough. And we know the model is good at coding, therefore we assume it's written well. And what are humans at the end of the day, right? Humans are, we interview people, we get a good understanding or an assumption that they are good at their job, and we trust the code, and then other people analyze that code and review it, and they become a good part of the team. But at the end of the day, we're moving to a world where people will not be checking the code, and 5, 10, 15 years, no organization is going to be checking the code probably. So schema is just a part of that. Schema is a way of guaranteeing that, in a way, one application uses or understands that data is in a certain format, and other applications can see that as well, and that's good. But we don't, you and I don't walk around going, well, the schema of this person has a name, and I will put that name of that person into that field. We don't think like that.
Well, we're quite, I think I challenge that in a way, because we're quite protective, aren't we, of our data and where it is. You've only got to look at GDPR to think about that. And I think for a while now, we've been fairly kind of casual about code, right? It's almost termed as us throwaway because it comes outdated. But our data, we must know where it is. We have sovereignty, we have a GDPR and my personal digital footprint. And it becomes almost emotional, doesn't it, for people? So I'm just wondering if people are willing to let go of their data as quickly as they are of their code, right?
Yeah, it's a good question. And look, don't be wrong, SurrealDB is not completely schemaless. It enables you to have completely, everything is strictly typed or strongly typed, let's say. Even arrays of vectors which are inserted inside an object, and there are many objects inside an array, and that is on the the tags field, let's say. Right. You can add schema for all of those. I do wonder though whether again it comes back down to if the LLM is managing that schema because we're not really looking at the code, then what does the schema mean at the end of the day? If it means enough for an LLM, then that's enough. But I totally get you. Data and the privacy of that data and where that data resides is important, and it's going to become ever more important. My question is more the platforms that are using that data, and those will not be necessarily humans directly anymore. We're not going to be looking at particularly at data or schema. It'll be the LLMs that are doing that, or the agents. And that in the same way that you've seen these AI agents starting to talk to each other in their own language, how we model schema wouldn't necessarily be the way that they choose to model schema. That's kind of what I'm saying. But don't get me wrong,
that's right. Yeah,
we would always have to have an understanding that this date is, it's the date of expiry of my passport, not the date of creation of my passport. That's important, right? I need to know which one it is. And another LLM who's looking at this for the first time needs to understand which one it is. So it definitely has to be labeled and, have schema, as it were. But I think the application reasons for that schema and us checking that schema will definitely
cold comfort in a way, isn't it? I think because we know the schema, we know where the data is, but that's not at all true. So
we touched on quite a few interesting topics there, though, especially around code and potentially not even needing to understand it at some point. And I had a guest at my meetup from Anthropic saying that he didn't even do a coding exam or any task in his interview process. He just has to understand it. So it's like everyone uses Claude. I mean, I'm using it. I'm working recruitment. I use it, but I think it all kind of flips back to that AI native conversation again. And I know you mentioned about memory and stuff like with agents and so on, and like AI applications need durable memory and relationships all working together. Like when I guess yourself or Surreal as a whole kind of talk about AI native, like what would you say is your definition of AI native?
That's a good question. Everything's AI nowadays, right?
Yeah, I'm AI native talent person. It's not what I say now. I mean, I've got an agent finding pretty basic. Don't get me wrong, but it's
I think for SurrealDB, AI native needs to work with in the way that developers who are building AI applications nowadays need it to work. Let's say so, and that comes back to if someone wants to build their way with a markdown documents on top of a virtual file system, it needs to work that way. If they want to work with an SDK through Python, it needs to work that way. If they need to work through MCP, it needs to work that way. So AI native is the ability to store, interact with and kind of connect with, but also store data in the way that AI applications or agents nowadays need to work. And then also I would say having the ability to interact and run with AI functionality directly within the database. That would say AI native. But I think it's a term that is changing every single day. Everybody is. I don't know many people who aren't using ChatGPT and asking questions of it. I guess it's a spectrum, and everyone is somewhere on that spectrum.
Yeah. It's come up in almost every conversation I'm having these days. Is how being AI native and how far on how far along do you go, like with being AI native, and do you have it just do everything for you? It's an interesting topic.
Yeah, and I think it also comes down to the problem being solved in the organization, right? If you're dealing with large amounts of money, you're probably not going to vibe code that part of the system yet. If you're dealing with government or defense, obviously we've seen the big conversation between Anthropic and the US government around, autonomous use of the AI for making decisions in the battlefield. This is something that obviously Anthropic aren't happy with on an ethical or maybe an accuracy perspective yet. That I'm sure will change in due course, but it depends on the application being built. It depends on, and it comes back to data as well, right? If you're using it to generate data, how happy are you with the output of that data at the end of the day, and storing and interacting with that data down the line? So
it's that abstraction thing, isn't it? We talked about abstraction when we were talking on the previous podcast, and it's how far do you go? History tells us that, it's a pendulum effect, right? We often swing too far one way and we come back to the middle, right, at some point. And we were talking about the fact that everybody abstracts themselves from the detail of understanding what's going on. So, well, who is actually stepping into that space as people progress through careers? And you kind of lose that body of knowledge almost because they retire and move on, right? And it's making sure that we strike the balance, I think, on control versus autonomy, right?
100%. But, and I think that balance is changing every day, right? As these LLMs, these providers, these platforms become even more powerful and knowledgeable and good, something that might have taken 8 weeks, 2 months, 3 months before can now be done, if you're using one of the fast models and the fast platforms, can now be done in a matter of seconds, if not minutes, right? And, and yes, look, right now, I still think it's at the point where you need to have, depending on the platform you're building, but you need to have an understanding of what it's outputting. So you need to be able to check that and understand it. But a year ago, that would have been a completely different story. And next year, it's going to be an even different story. So that balance is changing every day, right?
We'll see where we get to. So SurrealDB version 3, I sort of looked into this. You've re-architected it, the whole thing, to address some sort of like fundamental sort of inner workings of the solution. Tell us a bit about what you did there, and also I'd like to understand, how that decision process took place, and was it it was a big step for what I can see to do that, and some fundamental changes. So you want to talk us through that?
Yeah, changes across the board in a way. So for simplicity, I'll split it into 3 things. So in SurrealDB, there are effectively 3 parts. There's the storage engine, which deals with how data is written to, stored, and pulled out from the underlying key value store, the underlying storage engine. There's the parser, which takes the incoming query, parses it, and then pushes it through to the next. And then there's the kind of internal core executor and planner. This is the thing that takes that query, understands what it's doing, plans how to run it, and then queries the storage engine how to do that. We actually re-architected all 3 of those in 3.0. So the storage engine, very similar, but we've optimized how it's doing things in terms of how transactions are working within the code. So they still work in a similar way across the system, but within the code, they've been more optimized. The 2 bigger areas, though, so the query parser itself, going back to version 1 of SurrealDB, it was it worked in a similar way. We kind of parsed the syntax of that language, and then we executed that syntax in the database. And there was no optimization, there was no query planning at all in that. Version 2 was a kind of recursive descent parser, which optimized, made it a lot faster to parse, especially when you were dealing with kind of recursive or complex queries. And we didn't quite release it for version 3. We've got another version of the parser coming very soon as well, about to be merged. But I think importantly, so SurrealDB's query language is not just something you would find like with ANSI SQL, let's say, in Postgres or MySQL. It's effectively more like a programming language. So you can, I think actually one of our developers actually proved that it was Turing complete, and they wrote a whole UI vector array application on the query language itself. So It's effectively very similar to a programming language, but enables you to query your data and query graph data and query related data. But because of that, it's very, very complicated to reason about. Something can, it's very expressive. So something where you're maybe accessing the first value of an array could also be a field name, or it could also be going to a graph. So it depends on the data that it's operating on at the same time. So that becomes a challenge in how to optimize that. But we've optimized that, and we've written a whole new parser. And then the internal query engine, that's probably the biggest change right now. So we take that, the query engine in text, we turn it into an AST. That AST then gets converted into a plan. The plan understands whether certain things can be executed in parallel. So, if we're querying from table A and then we're querying from table B, we don't need to run query A, wait for it to finish, then query B. They don't interact with each other. So we can run them both together and get the results and then operate on the next query. In addition, how we then deal with that data, instead of kind of iterating over every single document separately, we're now executing over 10,000 documents at a time. So we're kind of processing documents in parallel, using the benefits of the CPU or GPU in some cases in order to get kind of better throughput on queries generally. And that benefits the system from traditional table selects, index selects, but all the way through to recursive graph queries and things like that.
So was that a long time coming? Was that something that you sort of knew was going to come, or was it suddenly a sort of epiphany moment? You said, "Look, we're gonna put stake in the ground and re-architect now." Because the reason I ask is because it's kind of like everybody kind of wants to do that. Technical folks often want to sort of re-architect and redo, because you can always do it better the second time around. So how did that come about? What was the?
I think version 2 of the database got to a point where we had functionality all the functionality that we needed, not all of it, but the predominant functionality that we wanted, we had. So we had graph querying, graph traversals, recursive, kind of arbitrary depth querying as well, arrays, objects, all of the functionality in the query language itself. Okay. And that was functionality. From a performance perspective, we wanted to go a kind of step further. Pre 3.0, there was a little bit, but there was very little query planning at all. So when you asked to have data from a table, we would go and get that data from a table and we would process every single document. Right. And we were doing that because working around the query language is complex because of what it can do, because it's effectively like a programming language. With this, definitely re-architecting it has meant a kind of massive jump in performance. I think in some queries they're 27 times quicker for some graph traversal queries. Okay. So and I don't know the numbers off the top of my head, but significant gains all around in terms of iteration through records and things like that. I think that the reason we didn't have to get to that straight away is because SurrealQL enables you to write very efficient queries. So in something like a join in a relational database, if you haven't optimized that, if you haven't optimized the join well, or if you haven't added the indexes correctly, you can get very bad performance. With SurrealDB, because of its graph-like nature and because of the ability to have a starting point. So in SurrealDB, you don't have to start from a table where ID equals Tobie or 1. You can start from person Tobie. And you can traverse out. And the traversals are O1 because they're going directly to a record in another table and so on. So you're never doing a kind of full table scan where it has to understand an execution. It works for a lot of queries. So up until now, you could get relatively good performance or very good performance in some queries and relatively good performance in other queries. With this, it brings the other queries up to the point where the very good performance was. So where you were starting out from a kind of specific record and traversing from there, now you can start from an entire table, which you could do before, but it's now even more optimized, and recurse through many different tables in a much more optimized way.
Because any of us that have written bad queries, and I'm certainly one of them, right? A few in my time. It's that compounding effect, isn't it? And then it's the compounding further under volume and under load, and you often uncover these things in production when it's like, okay, I did that the wrong way, and that join. And bad joins come back to bite you, right?
Yeah. Absolutely. And don't get me wrong, you're always going to have that, right? The slow query log exists for that very reason. Yeah. But it's about effectively having to. I mean, version 1 of the database didn't have indexes. We had unique indexes which prevented you from writing the same record with the same value, or different records with the same value in the same table, but there were no indexes being used for querying. And version 2 then, or version 1.5 then introduced indexes and the ability to query indexes. But yeah, that's because of the nature of the queries that are being run on SurrealDB can be run very effectively generally without indexes. But as you try to support lots of different types of modalities or different ways of querying, you have to kind of bring that performance up across the board, and that is something that version 3 aims to do, and I think has succeeded quite well to do.
Right, that's good news. So why would a Fortune 500 use SurrealDB? I know you've got some pretty big customers already. I just give us an idea of the compelling event to move from. We were talking before the podcast around the traditional sort of legacy databases that have been in there for 20 or 30 years. What's that compelling event to move to Surreal?
I'd love to say there's one reason, but there's many reasons. First of all, you've got cost, right? Data consolidation and data, or the opposite of that, data sprawl, which is what we're seeing generally in large-scale systems, but even more so in agent systems or AI systems. You have, one of our customers moved from 9 databases, to SurrealDB and simplified their stack in that way, and then scaled out to 30 to 50 nodes. So that's just one example. But ultimately, data sprawl and data complexity leads to increased latency, reduced performance, reduced accuracy. So increased latency because you're now having to query a graph database, a vector database, a document database, and more. And you may have to issue multiple queries to get back 100 results because you're having to compare those result sets on the application layer. From a data management perspective, obviously you're now managing in a highly available scenario 3 or 4 or 5 or 9 different database platforms. From an accuracy perspective, if you're having to execute a vector search, get back the result, we've got a result, now go and get a graph search. Okay, it's given us not quite the results we need. We now need to get more vector results. Now we need to go to a full text search index. Now we need to go to our actual core database, relational or document, and we need to get metadata. And we're building that up. The accuracy of that query is not going to be, it's not going to be as good or as efficient. And so, there's improved accuracy, and which is incredibly important for AI agents, where everybody is trying to chase the holy grail of getting an agent to respond in the right way with the right answer, not with something completely irrelevant. And we're also trying to do that quickly and with reduced costs. So ultimately, for a Fortune 100 or Fortune 500 company, it's about reducing complexity in infrastructure management, reducing complexity in the application layer, having to deal with different databases, reducing latency. And then I think the holy grail is improving the accuracy that the agents or the chatbots or LLM generally are dealing with. And I think that's incredibly important with Fortune 500 companies, because their data they're dealing with is large. It needs to be continuously up, highly available, highly scalable, and it crosses very likely many different types of modalities. So time, document, graph, and that is where SurrealDB simplifies it.
Right. I without sharing too much, I guess I would imagine you've seen a few interesting setups that you've come across evolved over the years. I mean, we call it technical debt, whatever. I mean, I've seen some pretty crazy stuff out there that you sort of just you have to laugh at it, right? Because you're like, well, how did this happen? Right?
Yeah.
And you've got to back it up.
We've all been there, right? We've all been there. Yeah.
What do you have any sort of stories you can sort of share around some sort of crazy database architectures or legacy setups that you get to
I think
with?
Yeah, I wouldn't say they're crazy, because I think it's the norm.
Well, yeah.
I think people. I think people have always jumped to systems that do what they need. And then, as coming back to the very first couple of questions in this podcast, it was, we're bolting on or acquiring a provider or a platform, and that whether that's a database company or whether that's an organization, this is the same thing that organizations do. They'll choose a platform, they'll then go, oh, we need this. And maybe it's, the decision is made on high or something like that, and bits are added on. That over time can be, complicated. Every single deployment that we see out there is different. People are using relational databases for things where relational databases aren't suited for. They're using graph databases for things that graph aren't suited for. They're adding in this is the other thing I didn't even talk about, ETL and the complexity of ensuring that data is consistent across all those different platforms. That is a spaghetti mess in itself, right? And ensuring that data is up to date, is consistent, is accurate, that the right data is going to the right places. That kind of compounds the situation. So I wouldn't say that we've seen anything crazy, because we're so used to seeing very complicated setups. And you go to any tech talk today, and you'll go to it and you'll see an architecture diagram, and there'll be 1,000 things on that screen. And that is what organizations are looking at. But it becomes very hard to build effective AI and to scale that in today's day and age, when you need to iterate quickly, and you're looking to get the best accuracy and out of your agent memory, let's say, or your context layer. So
I think the ETL thing you touched on, we probably should have talked about that before, because there's over the years some crazy stuff's happened now. I mean, I recall it was a utilities client actually that was dropping out their entire asset management SAP database. It's not really a database, into a text file. And that was happening every night. And it took about sort of 6 hours, and there was a rush. If it ever crashed, it would have to not complete, because there wasn't enough time in the night to do it. And then that was getting, taken back up and transformed into another Oracle database somewhere else. And we sort of looked at this and was just like, oh, wow, why was this done? It was like, well, the two don't talk to each other, and it was the easiest way to do it. And it's been running like this for the last 10 years. And, it kind of works. And sometimes it doesn't, it fails, but that's okay. And it was, and just looking at things like that take place, that sprawl and those sort of knee-jerk reactions are just...
Maybe that was the AI agent memory system that they were building way back then, right? You never know. The single flat file that stored the entire organization's database. I mean, you see this with stored procedures as well. You hear these stories about, a 1 million line stored procedure that no one can touch, because no one really has an understanding of what it does. But it works, so don't touch it. And we'll just keep continuing using that for years. And that, that's another example, right? That's why functionality, in that particular case, that's why functionality should be built and developed outside of the database and added in, because then that can be iterated on in the way that developers would want to iterate on things. But that is, that stored procedure probably started out as 10 lines of code. And over the course of 10 years, it became much bigger. And then at some point, there's a line drawn where people can't touch it and can't edit it, because no one really knows why, how, or what to do about it.
So I think Emma touched on that, right? When I think she a bit of her code was running for 8 years before, and she'd left the company already, like for 8 years before anybody was allowed to touch it, or just deleted it, I think, in the end. So.
It's a skill sets as well. And you talked about, stored procedures. I just used to avoid them, right? Because I wasn't a database guy, and DBAs, it was a craft almost, right, back in the day. And they spoke in SQL, and everything could be done in SQL. And you were almost, sometimes a few of them would be like, well, we don't need a developer, I'll do that in SQL. It's more efficient, it's quicker. I remember seeing a guy that used to just basically do mass sort of database sort of transactions and migrations just using DOS, and that's all he used, and it was all bash scripts, and that was all he would use. And you're kind of locking out a huge portion, so everybody sort of went into their tribes, and as a result these things would just evolve because that individual knew how to do it. And you're right, you wouldn't touch it. And I wouldn't touch a stored procedure. I'd see it hanging in the database and go, oh no, not one of those. But I go and call the database guy and to look at it, and nobody wanted to touch it. And it's just legacy debt that we're all having to deal with. And I would
say some people are probably quite precious about it as well, right? It's their baby. Potentially it's like, so you don't want no one to touch it, or specifically don't want anyone near it, and
definitely
keep it out there, keep it going. Otherwise, might be out of a job if someone else can come do it better than me.
And that's AI is going to change that. AI is definitely going to affect that aspect of the role.
And that's why calling out to developers, if you can write it in Rust, then suddenly that sort of opens up the team a bit more and stops that tribal behavior of the database guy does his thing and the software developer does there. And then you've got the 3-body sort of setup with the developer, the computer, and then the agent also in the mix, and everyone's going, well, hang on, the agent can do all of this, right? And I guess with AI you start to get more optimized designs anyway, because I know when you start to use AI to do your design, whether that's for a database design, a database data architecture, because it's often fundamentally missed is data architecture in this world, as well as software design, you're getting sort of the best of all breeds there, because you're an agent that's not partial to that sort of, this is my area, so I'm going to do it this way.
Exactly. And the ability to understand that code. I think that's, even if writing it isn't totally there yet, or you don't totally trust it yet, but the ability to understand what a function is doing without having to look through the code, the ability to do that in a matter of seconds is a game changer. I've
actually had projects recently where we've been able to do that. We just say, this is what's happening.
Yeah.
And it was just, it was a epiphany moment. It was like, oh wow, now we know exactly, we don't have to sit there and unpick that. Yeah. And that is massively helpful, and that's the way we're all going, right?
You've seen if it was last week or the week before, Anthropic now being able to write or modify COBOL, into modern code, whether that's, I don't know what you can write into, but that was a whole industry and profession before of people who were specialized in that, and now AI can probably do it quicker, and better.
That was the big banks. There were so many of the big banks that say about core banking solutions written in COBOL. Everybody's retired, and there was this sort of like, you could make a good living as a COBOL contractor out there, just troubleshooting these systems, and it's a dying art, right?
Absolutely.
So I guess 5 years from now, I think the data layer as a whole could look very different, right? I don't know if you've got any views, and I'm not asking you to predict the future here, because none of us can, but clearly in that remit, what do you think is going to happen over the next, as we could, 2, 3, 5 years?
Yeah, I think, coming back to our conversation today, I think definitely there's going to be a push to see more privacy focused memory for let's call them agents, but whatever they turn out to be, helpers, companions, agents. There's going to be more of a focus on privacy, locally running compute for privacy purposes and for cost reduction purposes as well. And we're at the beginning of this understanding that the data platforms and the data systems that we've used up until now have not been good enough for what we're building next. So, I think obviously Surreal is one of the platforms, one of the providers that fits nicely into this into the industry as we go forward. But ultimately, that is what we're going to be seeing. We're going to be seeing databases that can work with data in many different ways, can scale up. If we're dealing with a Fortune 500 company, let's say, they need to scale up to petabytes and do that relatively cheaply, because otherwise that will cost a lot. But also, to improve the accuracy. We know that the issue nowadays is no longer to an extent, but it's no longer really the large language model or the number of weights or the amount of compute. Sure, we can get quicker. We can generate 50,000 lines in a few seconds rather than 5,000. But that's the game changer is going to be the data, and the organizations that are going to succeed are those ones who can know that they have we're working with a client who needs to guarantee greater than 98% accuracy on the output of its LLM, and that is specifically in a defense context. But that's any organization that can ensure good accuracy or a certain level of accuracy, or almost 100% accuracy to the for the context of their business, they're the ones who are going to succeed. And it goes without saying, right? If I'm going to launch a customer support agent, and that customer support agent answers 60% of my questions right but 40% wrong, it's going to result in a lot of customer churn, a lot of dissatisfaction. So it's going to be about data. It's going to be about the organizations who use and utilize and build on that data in the best way. And I think personally, I'm a believer that SurrealDB will be one of the defining databases or data platforms for that agentic movement or agent movement as we go forward.
Yeah, absolutely, I believe as well. It's been great listening to talk and answer the questions, and it's quite admirable. I think founders, that makes a great founder is being able to be adaptable. So like the fact that you've got SurrealDB 3.0, it's growing. You've got your funding again, which we haven't touched on yet. Congrats, by the way, on that for the Series A. I just wanted to ask on that, like how hard is it really to guarantee a 98% accuracy on your?
I think it depends. I mean, I can't go into the project itself too much, but effectively, these the decisions that are formed off the back of the output of that LLM can dictate a life or death decision, and therefore, you have to, whether it's 98% or not, but you have to have a very good understanding that majority of the time this system is giving me a result that I can trust. Again, it comes back to that previous discussion. It is non-deterministic, but it's about that model will always be non-deterministic. It's about feeding in the right data and the best data and having as much of that data as possible to hand. And this is something that's running locally, so it's completely air-gapped. Having that data running, available to hand so that those decisions can be informed. It comes back to, an agent is no different to a human, right? Yeah. If I go into an exam and I haven't done any revision, I'm not going to do great, probably. If I've got all the knowledge I could get about mathematics and I go into that exam, I'm probably going to do better. So, it's about data. It's about the data that goes into that system. So, no, guaranteeing, I don't think is something we can do with a deterministic system, but having an understanding that the majority of the time, this is something that I can trust. And, the majority of the time is in almost 100% of questions and answers, then that is, and every single system is different, right? That is something that it literally affects the decision being made. And some are less, some systems will be, take that with less importance, let's say, but it's going to be a factor as we go forward.
Nice. Yeah, I can definitely vouch for going to exams with no revision from my school years. So, so I guess on the Series A, congratulations. It's quite recent as well, right? Last week, was it? Or
that's when we announced it. Yeah.
Literally last week. Yeah. So congrats. But I guess my question, and from the industry that I work in specifically, like what's with this funding? What's the kind of next 12 to 18 months looking like for SurrealDB and growth? A lot of growth, I would imagine, maybe. So
yeah, I mean, so for us, we've built a significant amount of product up until now, but the space is changing, iterating every single day, and it's doing that quickly. So keeping up with that. So we have an exciting addition coming on the product side, which is Postgres wire compatibility. So that's the ability for you to query in Postgres, to write joins if that's what you love. But behind the scenes, we're storing data in a graph-like format. So you can immediately connect with the tools, the business intelligence tools, the analytics platforms, the ORMs, the SDKs that you use as a developer or that AI kind of recommends you to use. But you can then, down the line, you can then query that with graph or time series or relational. So you can query it in the ways that SurrealDB stores data. So that's one thing that we're working on. Other than that, I think it's about building our go-to-market team. So we've always been just focused on product, just focused on developers and building a great platform and product for developers and organizations. A lot of the organizations, or pretty much all of the organizations that we work with, have come inbound. So they find us through developers or engineers or senior architects at these organizations, and then they decide to give it a go, try it out, and go from there. Obviously, our next step is to go out there and talk to more people and sell to more people. So that's one of the things we're building with this new round of financing. It's building that go-to-market team. But it goes without saying, we're a tech platform. We've got to continue building a great product for developers and continue working on optimization and performance and functionality and integration and interoperability, along with building I think another thing I've missed is as we work with large organizations, the ability to support those organizations, not just making sure the databases are up, but actually making sure that when they are building against SurrealDB, that they are able to get the accuracy that these AI agents or applications require, that can reduce their costs, that they can simplify their infrastructure. So support, go-to-market, and product, basically everything you need to do.
Yeah, lots of FDEs now, maybe.
That's
more of them.
Getting it out there and then supporting it longer term, isn't there? That's the key. And that's your cloud platform as well. You've obviously, you can go on-prem, you can go cloud with SurrealDB, right? And
absolutely.
You can scale that as well.
And I think, as you work with large organizations, you can't just force everybody into the cloud. especially given the conversation we've had today, which is, more of these organizations need to be in control of their memory, need to be in control of their data, or maybe even need to run it completely air gapped at the edge or on device. It's we have an kind of on-prem version. We have a community edition, we have an on-prem enterprise edition, we have our cloud edition as well. Whichever way is best for an organization to run, that's their choice.
So I'm going to ask one question, and then Rhys is going to ask his question, which is his favourite one. I want to ask, if going all the way back to those early golf thesis days, which I actually read your abstract of it.
Thank you. You're one of the few.
And if you could do something differently, right? What any learnings for other founders or just people in the industry that you would say, if I'd known that now, then I would have done that differently?
It's a good question, because there are so many things, right? You're as a I guess as a founder of a startup, but also as someone building a platform like this, especially in today's day and age, because the industry, the marketplace, as it were, is changing so quickly. Before, 10 years ago, use a document database, yes or no, and that was kind of the choice. Nowadays there are lots of different ways of building agent memory or applications generally. There are lots of different ways of architecting it, and so I think there are lots of things that we might have been should have focused on earlier, maybe. Integrations, I think for us it's quite specific for us, which is we're building everything from scratch, and therefore we have to integrate with as many different providers as possible, because we don't have that ability to kind of connect directly into an ecosystem that already exists. Having said that, that's also a cost thing, right? Having to build every SDK and every ORM and every platform connector is something that takes time and needs resources for. So, but ideally we would have been able to build those earlier on. I'd say, I don't know. I think in terms of as a startup, right? It's. I think this is something we do, but I think every organization can always do it more. And I think it's not necessarily an unknown out there. It's just understand your developers, understand your users, talk to users as much as possible, so you're understanding what they're building, why they're building it, why they like it, SurrealDB, why they don't like SurrealDB, what are the choices for them to use or to migrate to SurrealDB. Just understanding. I think we do that well. We have a large community of Discord users. We're active on GitHub. I think it's something you can always do more of. It's just if you can have the time, if you can find the time, right?
Right. Yeah.
I mean, I've actually got two questions I want to ask, and one of them is specific to agents, because I mean, I'm building. I come from a non-technical background, right? So just, unlike you two both, but so I'm always interested in finding out best practices around building agents and stuff like that. So I will ask that question now, which is always something I ask. So in your perspective, I think we may have touched on it previous as well. How would you build an agent in terms of best practice? Like, what's your go-to, or if there even is a go-to? And I mean, like you said, it's so different and changing all the time. How would you build an agent best practice-wise?
I think it obviously depends on the level of expertise you've got with code. So I approach this answer with my technical background. So for instance, there are platforms where you can type what you want the agent to do, and you don't have any concept of how it does it behind the scenes, and that works, right? For me, I still want to have a little bit of knowledge and control about how it's doing it or what it's doing. So the ability to I think there are some great Python frameworks out there that we're integrated with. Like we've got Agno, there's Pydantic, there's Crew AI. These platforms that enable you to build agents, and then obviously goes without saying, SurrealDB as the data layer, right? I couldn't suggest anything else. But there are so many platforms out there that enable you to build agents without having understanding of what it's doing. So I'm not a massive expert in that area because I don't use those per se myself. But having said that, there are some functionality that we're building into the database which enables you to again, reduce that infrastructure even more and enable you to kind of simply scale out your agents. Because one of the challenges that we know organizations are hitting is it's very, very easy to build a POC. And to, if that POC is something like, okay, look over my Twitter feed and generate me a response for this, then that's fine, right? That's something you can get into production. If that POC is support agent or product recommendation or ad serving at massive, global scale, then you need to have an understanding that your agent is making the right choices. And again, it comes back to kind of accuracy or level of confidence. But many of those projects fail to get out of POC because, one, they're not able to get the accuracy, or two, they're not able to kind of deploy in a way that can scale up alongside the data source as well, or database. So that's something we're looking to solve with SurrealDB as well. How do you scale your agents? How do you move them into production and kind of not guarantee, but aim for good level of accuracy with that as well? But I'd say right now there's some great Python frameworks. There's some good JavaScript frameworks as well that you can easily build your own agents with. You can vibe code elements of it as well, so you don't have a good understanding of the code. But you can build some pretty amazing stuff with these. And I vibe coded myself an app the other day which links into Twitter and pulls out everything that's relevant for SurrealDB and can generate responses and everything. It's amazing how quickly you can build these applications, which would have taken months before.
Yeah. It's just, obviously I find it fascinating, and I mean, I'm involved in this industry, so it makes sense for me to learn. But I mean, I've been building my own agent for talent and stuff like that, and it worked, which was bizarre. I was so buzzing it actually worked. So it was stuff like that. But it's just great to get an understanding from the perspective of yourself and as a founder as well. But I've also got another question I wanted to ask, because I find it quite interesting in terms of something that I can kind of relate to on a much smaller scale. So obviously, you've got SurrealDB, family business, right, with your brother. I had a very, very small shoe cleaning business with my brother. Obviously, nothing on the scale of what you're doing, but I've gone from doing a suplex when we was kids on the bed, like wrestling moves, to doing a business together. It was a nightmare. Working with him. So I just kind of wanted to ask, what is it like that's been building a fantastic business with your brother?
Yeah, I'll come back to that. You said something at the end of your last question, which was you were amazed when your agent worked. I think we were all at that stage, right? We were all like, even me, I'm like, I know the capability of this model, but when it does something, I'm like, oh my god, it's so amazing. And it's like we're still experiencing that when something works, when you build something, it works, and it does it so quickly. It is amazing.
I did. Got such a good kick out of it. It was crazy.
Yeah. So come back to my brother. I mean, look, we are very, very different. So the entire brand, the entire color system, if you look on our YouTube page, everything is purple and pink and on brand. So that was all Jamie. Everything from the front end site, managing the team internally, and then kind of focusing on the growth and go to market. That's my brother's side. In terms of the vision, the general direction of the product, and the general direction of the company itself, that's my focus. And obviously, being on streams, being at events, being doing talks and things. I think it helps. The fact that we are very different, we have very different skill sets. We don't overlap in that way. We obviously talk about everything and talk a lot. And I think the other most important thing is trust. Yeah. As you see, so many startups fail because the founders fall out, or the founders have different aims or different visions of where the company should go. And I don't know the actual statistics, but I'm going to guess it's one of the biggest reasons that a lot of startups fail.
I've experienced it myself not me, but in a company I've been in. I've experienced what you said, so it's out there. It happens.
Exactly. And Jamie and I, we fight, right? We're brothers. I think that's one of the good things. You can fight, you can argue, you can disagree, but at the end of the day, we still have that complete trust that we have the same vision for the company, we have the same desires for the company, and we have the same trust and respect for each other. And that makes running a business far, far easier if you can have that. And, I think, it would be very different if, one, we didn't have that trust, and two, we overlapped in certain ways, let's say, because you're going to be treading on each other's toes, you're going to be having different ideas, and that makes it harder. But yeah, so we've worked together for a long time now, before we built SurrealDB, and we don't always get along, but it is great working together.
Yeah, it's awesome. It's good.
That's good. Right, so Tobie, thank you so much for joining us today. Really appreciate you taking the time to come in and talk with us. It's been a great conversation, and obviously wish you and SurrealDB all the best in your forthcoming venture.
Thank you very much, and it's been great to be here to answer these questions. I love the conversation.
Great, thank you.
Appreciate it.